Welcome to queenon7.com. Please like, share and subscribe my videos. Today we're going to learn about the cells and batteries. Cells and batteries can be constructed by using different metals. In the previous videos you actually have looked at the reactivity series. Different metals has got different reactivity. If you look at the reactivity series, the top one on the reactivity series is more reactive as compared to the one in the bottom. So there will be a potential difference between the two metals if they are connected into the same cell. Now cell can be constructed by having two different metals. Now if you have a metal, for example, you have aluminium. So if I will say this is made by aluminium and this is made by copper, aluminium is more reactive because it is on the top of the series. Copper is actually less reactive. What it means, I'm going to explain that in a minute. If you put these two metals and connect them, or you put a voltmeter there, and you have a solution of electrolyte. An electrolyte can be an ionic solution of any ionic compound. So this solution is called as electrolyte. A cell can only produce electricity for a certain period of time. If you look at the clock, when you use actually cells in the back, it can be used only for a certain period of time. The reactants you have in a cell, for example, if you have, this is the cell, like a Duracell, you have, and you put, it has a lead pencil inside, and it has a mixture, this one, there they have a mixture of probably carbon, and it will have manganese oxide or another compound. That will be positive, and obviously it has got some seal as well. So this is just a normal cell you use in the clocks or in other toys. After some time it's gonna run out. That means if you try to recharge it, it's not gonna recharge because the reactants have already used up, or in chemistry we can say the reaction is actually stopped. When we look at this cell, when you have two different metals, for example aluminium or copper, they both have different reactivity. Now the reactivity means one is powerful than the other. So if I say you have aluminium and you're going to react it with an aqueous solution of copper sulfate, this metal which is solid, the moment you can actually react it with a copper sulfate aqueous solution, it is going to replace it from its salt and produce copper solid. So in that sense, the copper will be actually deposited on the electrode. Now aluminium is actually in the zero state and will make a copper as in the solid state. Anything which is in the chemical reaction is written and just on its own as an atomic form, it will always have a zero oxidation state. So there is no charge, it's a complete atom. So in that case, the copper, which is actually in 2+ state, will convert aluminium 3+ state, and the actual formula is Al2SO4 thrice based on the negative charge on the sulfate and aluminium. So that is the actual formula. Because it has replaced sulfate out, that means aluminium has gone from 0 to 3 states. So you can say aluminium has gone from 0 to 3+ state. That means it has lost 3 electrons. In anything which lose electron, loss of electrons is called oxidation. And copper, on the other hand, which was actually in +2 state, is converted into 0 state, means copper has gained 2 electrons, become copper metal, and that will be the gain of electrons, and that gain of electron in chemistry is called reduction. Now when you construct a cell, you always take two different metals. So for example, you have taken aluminium and copper, that will show you a huge potential difference on the voltmeter, because they both are far away from each other, so they will produce high voltage or high potential difference. And if you take only iron and stainless or stannic, whichever metal you take, is called tin, that will show you a low potential difference. So it's not going to produce much of the current. Now, based on this theory of the potential difference, why do you think that the copper and aluminium are actually showing you the potential difference on the voltmeter? And the theory is pretty much easy to understand. Aluminium and copper, they will exchange electrons. If you see that aluminium is going to lose electron and copper is going to gain electron. Let's go back to the reactivity series. Aluminium is more powerful than the copper, so aluminium will actually oxidize and copper will gain those electrons. So for example, if this is made by copper and this is made by aluminium, aluminium will lose those electrons in the solution of the electrolyte. So you have a solution where the ions are moving. Those ions will actually take those electrons and responsible to deliver it on the other side. So these electrons will be discharged from the aluminium, because aluminium is more powerful, so the electrons will flow from aluminium, and then it will actually be delivered to the copper, and copper will gain those electrons. So the electric current will actually pass through this from aluminium to the solution and all the way to the copper. So that is a sequence. So because it can conduct electricity being an ionic solution, that it will go back and the potential difference will be shown there. So flow of electron in chemistry, we call it as charge. The rate of flow of charge is called current. So whenever you see the electrons are moving or can move, that is called the flow of current, or you can say the current is actually passing or showing up. Now, based on that theory, we can actually think about that when the whole reaction stops, the cell's gonna stop. So some of the batteries which are actually chargeable, some of them they are not chargeable. So the one you are actually say they are chargeable, I've already explained non-chargeable. The one you cannot recharge is because whatever the solution you have inside, the electrolyte you have, is finished, it's ran out, the reaction stop. The one you can charge, for example, you use in your phone, the landline at home, you can just put it back onto the electricity, or you connect it with electricity, and it actually recharge those battery, and they can be recharged all over the time. And it's because you reverse the process. So the whole process of the what do you call it as current passing through the battery can be reversed by using electricity, and that's why those batteries can actually start storing those current from the electricity, and then you can actually use them in your phone or wherever you want to use them. Now there's another part which is very important. It is depend on the strength of these metals, how strong they are and how far they are from each other to create that potential difference. It also depends on the solution you're using, means electrolyte. So the electrolyte is actually an ionic compound. That ionic compound is actually made by a metal and a non-metal. So sodium belongs to the first group, chlorine belongs to the seventh group. Metal is reacting with the non-metal, and it will produce sodium chloride. And when you put in the solution H2O, it will convert into Na positive ion plus Cl negative ion. Those Na positive and Cl negative ion can flow in the solution and exchange the electrons and will be responsible for the electricity. Thank you very much. Now we're going to look at the batteries. Batteries and cells both can be rechargeable or both can be non-rechargeable. Batteries can be constructed by actually connecting the different cells or same cells in series. So you can have more than one cell when they are actually constructed in series or connected in series. That will be called as a battery. If we can draw one cell, for example, you have a beaker or obviously a container where you have a solution of a ionic compound. Ionic solution can be sodium or chloride ion. You have two metals, for example, you have aluminium and you have copper, and you have another cell where you have two electrodes. One is made by copper and other is made by aluminium. Copper is obviously more reactive, and the electron will pass through from here, so that will be positive and that will be negative. That will be positive and that will be negative, because this is gaining electron and aluminium is losing electron. That means oxidation is going to happen. Now this is also ionic solution, so if there is no ionic solution, the electrons cannot pass through. So electrons will actually flow from aluminium to copper, because aluminium is more reactive as compared to copper. It will be the same. Now you have two different cells. Before you put the voltmeter there, but this time you are going to connect them in series. That means you are going to connect the copper with the aluminium of the other. So negative electrode is connected with the positive electrode of the other cell. In the same fashion, you will have the negative electrode of the other cell connected to the positive electrode of the of this cell. Now current will pass through like this. You can see that the electrons are flowing from this direction, so it will be releasing those electrons, will be actually captured by copper, will flow all the way there, coming back and then release again and then going back all the way. So the circuit is complete. The electrolyte is actually something which is responsible for flowing the current. The moment your electrolyte is actually runs out electrolyte, you always say the cell or the battery, at the moment we're talking about battery, is dead, or you will say it's flat, it's not working. That's one of those. So the potential difference depends on what type of metal or electrode you're using, and also what type of solution you're using. As long as you can reverse the process by using electricity, so the rechargeable ones, rechargeable electric cells or batteries, the reaction is reversed by using electricity. In non-rechargeable ones, even you try to connect with electricity, it is not going to reverse it, but in the rechargeable cells and battery, the reaction can be reversed. That's why you can use them in your landline phones or other different equipment. Thank you very much.